Hello everyone, thank you again for joining us for today's webinar. Today I'm going to be talking about full color 3D printing and how to generate model files for it. My name is Neil Foley, I'm the applications engineer here at Rise, and I'll just get it started. So to start with, full color 3D printing is useful for all sorts of different things. I have a few examples here. It's useful in engineering for being able to communicate various simulation effects or things like that using the variety of different colors you can apply to surfaces. It's also useful in life sciences for differentiating among different body parts or color coding different things for the various functions you might need organic models in the life sciences. It's also useful for product design, being able to test out different changes to your packages or things of that nature. And it's also useful in geography, geology, and architecture in terms of being able to show realistic mapping or architectural designs using the full spectrum of colors. So here are some of the things I'm going to be going over in this webinar. I'm going to start with some of the basics of color models. Then I'll be looking at the different types of file types that can be used for 3D printing with our software. Then we'll be looking at a few different kinds of software. Each of them is typically used in a different industry, or in some cases a different stage in the development process, and each of them have their own advantages and disadvantages. So that will include engineering software, mesh diagnostic software, which is more often aimed specifically at 3D printing, artistic meshing software, which is used more often for graphics, and Rise One Touch software, which is our Rise's proprietary slicing software. And then after all of that, I'll be looking at some advanced color model file manipulation, which is typically not necessary, but if you manage to understand that portion, then you'll be a master at being able to get color files ready for printing. So here are some of the basics that you need to understand before generating color files. First is the difference between color and image textures. So color would simply be when you apply a solid single color to a surface or the face of a part. An image texture would be when you have an image file that can be mapped onto the surface so that you see the whole variety of different colors in their proper positions. Another important difference you need to know is the difference between meshes and mathematically defined models. So by mesh, I mean a model composed of typically triangles, lines, and points that is normally represented simply with a set of coordinates and the lines and faces that connect them. Now, mathematically defined models can be much more complex, and these are the types of things that you work with in engineering software, where a single surface will be represented by the equation of a sphere or a cylinder, rather than a set of discrete triangles. Some of the other things that we'll be talking about later include mapping, tiling, and color picking. So mapping is the word used for the way that an image file is attached to a part and how exactly it's oriented and scaled and all of those things. Tiling is a word that's used to describe when an image texture is not just applied a single time to a surface, but it's applied in a repeating pattern over whatever portion of the surface is intended to be affected. And finally, color picking is something that I'm sure most of you are familiar with. It's functionality in programs as simple as Microsoft Paint, and it's simply a way of selecting a color that's already present on a model and being able to use that to apply it over a greater portion of the model. And finally, there's the 3D printability of graphical models. So often when color models are produced in artistic software for the purpose of use in graphics or computer-generated movies and things like that, they are not really created in a way that's conducive to manufacturing. So oftentimes there will be open surfaces, which could either be holes, missing triangles, or it could be that they only modeled one side of the model and the backside may be totally empty. And so that would be an issue that would prevent that model from being printable. Another possibility is interference, which is when surfaces intersect with one another, which can pose some challenges to some slicing software, especially if you have a large number of surfaces all passing through the same area. So now we'll get started with the different textured model file types that can be used in Rise software. So the most commonly used file types I've found are the OBJ and the WRL, sometimes called VRML. So OBJs are a file format that are stored in plain text. So it's actually possible to open this file type in Notepad and view the numbered coordinates of the triangles and also locate references to other files. So OBJs are only able to store color and images by the faces. They can't store them by vertex. So it's more difficult to create gradient types of color models using OBJs unless you create those gradients using images rather than colors. OBJ files also require an MTL reference file. An MTL would mean material. So this file is included with any colored OBJ to connect each of the triangles to the correct set of colors or image vertices. And the other thing you'll have to include alongside MTL files are the actual images that are referenced by the MTL file. So then there's the WRL. WRLs have a bit more flexibility than OBJs. They can store color and images not just by face but also by vertex. And oftentimes the images that are included in these files are included within the file itself. So you don't need to have separate images. However, that's not always the case, especially if the images have large file sizes. And in those cases, you'll have to make sure that you bundle the image files along with the WRL. There are a few other file types that are seen less often. Those are 3MF, PLY, and FBX. Each of these files, including the OBJ and WRL files, have sort of their own niches that are they're most often used for. So depending on the type of industry you're working in, you may see one more than others. Another note at the bottom here is that although these are the only file types that support color that are currently imported by the Rise OneTouch software, we do have the capability to add additional file types if there is sufficient demand for them. So now we'll get started talking about how to create or modify colored model files using engineering CAD software. So most engineering CAD software is great for creating new meshes because they are very effective at creating very precise mathematically defined models. They're usually pretty good for applying color to faces, and they can be good for applying simple images to simple faces, although more complex image mapping can become difficult. So I go with the example of SolidWorks. This is the engineering software that I have the most experience with. So I'm going to go through a demo in a few minutes where I'll cover a couple different things you'll need to know about creating color files in SolidWorks. This will begin with applying and manipulating appearances, which will involve selecting the geometry that you want to be affected, and then selecting the color or image that you want to apply. And then there will be some options for placing, projecting, scaling, and orienting. and then I'll go over a couple of the other things that you'll need to ensure you do to get a successful file. So I'm going to switch over to SolidWorks now. So I already have a part file open right now. So this part is already colored green. So you can see over here on the top left, over on these tabs, that the last one is the Appearance tab. And this is where we can add or change different appearances. So the first thing I'm going to do is right click and select Add Appearance. And that will open a new window. So this first section is where you determine which geometry will be affected by the new appearance. So currently it's tabbed to selecting a part, and the entire part is selected. But in this case, I don't want to color the entire part a different color, so I'm going to delete that from the list. And then I'm going to choose one of these other options. I'm going to go with selecting faces. So now that that's selected, I can just add whichever faces that I want to change the color of onto this list. So I'll just add a few of these, and that's good for now. So right now, the color that is being applied is this one right here. I can open this box and choose a different color, or I can make adjustments down here in these color boxes. Now, if I want to, instead of using a solid color, apply an image, then I have to go up here to the Advanced menu and then change this file path here. So I'm going to go to, let's apply brainstem map. All right, so I applied a color map for a brainstem, which is sort of just a mixture of various different colors. So it doesn't look all that great on this part, but one of the things I can do is change the mapping of this texture. So right now it is rather small, and it's being repeated over and over again over the entire surface. So I'm going to select these two, and now that scales it up so that the part fits over this surface using its entire area rather than repeating itself. So there are some other options down here. You can mirror in either direction. One of the things that you're not able to do in SolidWorks is turn off the tiling. So if I didn't want to fill the entire face of this part, then I could scale this down. However, that results in the tiling that we saw before. So unfortunately, I'm not able to turn off this tiling option. So if you want to only color a small section of a face with an image, then you'll need to find a way to only select that portion of the face. This could be, in some cases, done with an embossment or an engravement. So I'll give a quick example where if I only want to place the image on that small portion of the part, then I can create a small protrusion, and I'm going to make it very small, let's say 0.01 millimeters. So now that hasn't really changed the geometry of the face, but now there's a separate face here that I can select when creating an appearance. So I'm going to go back into Appearances. I'm going to select the same one. And then I'll select the same face that I had before. There we go. Now I can do the same sort of mapping where I fit it to the width and height. All right, so I think if I check this off, it's going to tell me I need to save the appearance file, so I'll do that quickly. Or not. All right, tell you what, let's just color this one with a single color so that I don't have to save a separate appearance file. And then we'll get on to what you need to do to save this model file. So I'm just going to go with a solid color on that, and sounds good. So when saving a file from SolidWorks, in order to preserve the color information, you have to choose a specific file type. So I'm going to go to Save As and open this folder. So there are a few different file types here that Rise Software supports. There's the WRL, the STL, and the FreeMF. Now the STL doesn't contain color information, whereas the WRL and the FreeMF do. However, if you save as a WRL from SolidWorks, it's not going to preserve the color information. So it may preserve solid colors, but it definitely won't support image files. So instead, we're going to go with the 3MF file. And this is an important part. Once you have 3MF selected, the first time you do this, you'll have to open this options menu and make sure that this box right here, include appearances, is checked off. As long as that's checked off, then all of your appearances will be included in the resulting file. So I'm going to save that in here, and then we can open that file in Rise Software a little later on. All right, so I think that covers everything we have here. The one other thing I wanted to mention is that another thing you can do in SolidWorks involving color without appearances is creating simulation models. So if you use SolidWorks simulation and create a model with stress data or displacement data, then that will color the surface of that model using a whole spectrum of different colors. And in order to save that, what you'll have to do is right-click on the set of results from the list and save that as a WRL. And in that case, it will preserve all of the color information that you need. So the next type of software that I'm going to talk about is mesh texturing and diagnostic software. So this type of software is typically great for fixing defective model meshes. This can include some of the issues that I mentioned earlier, holes in parts, open surfaces, or interference. And it's also great for applying image textures to complex surfaces. So the example that I go with is a piece of software that I'm quite familiar with, which is Materialize Magics. So Magics is good for, as I mentioned, applying and manipulating color and textures. So I'm going to open Magics and give a quick example of how to do that. Same as SolidWorks, it'll primarily involve selecting the affected geometry, selecting the color or image you want, and then manipulating the image texture until it's positioned as you desire. So here is a brainstem. In this case, our brainstem is colored incorrectly, and that's because there is an issue in the file type, which I created, and this is something that we're going to solve a little later on. But for now, I'm just going to show you how to apply some color to a part in Magics. So right now I have an option selected up here. All of these green buttons are for selecting different parts of the geometry. So I'm going to choose Mark a Surface, and hopefully this will not mark the whole thing, but it did. All right. Instead, I'm going to choose Selection Box, and I'll select this portion of it. And now what I can do is go to this Texture tab, and the Texture tab will include both the ability to apply textures and the ability to apply solid colors. So if I choose Paint Part, then it gives this option to select a color to apply. And if I choose that color, then I can hit Color Marked. And I actually have to turn off the texture, and now you can see that color. So in this case, I would actually have to remove the texture from that surface that's already there in order for this color to appear on the final part. So if I turn that back on, I'm going to pop back over to presentation now. So a few of the limitations of Magic include the fact that it's only able to apply color by face, not by vertex. So this is certainly not an issue when creating OBJ files, but the ability to apply per vertex color that WRLs offered is not done by Magix. So Magix, in addition to allowing you to apply colors and textures to parts, also has a lot of very powerful tools for diagnosing issues and automatically fixing them. So if you're working with a part that has very complex surfaces with interference and holes and things like that, then Magix is a great tool for solving those things. Unfortunately, Magix is not as effective at doing some more simple operations like moving or scaling portions of the part, and trying to do those things in Magix can involve a lot of work that requires breaking the part down into multiple separate pieces and then rotating them and recombining them individually. So now we'll talk about artistic meshing software. So this software is very good for modifying and manipulating meshed model geometry. It has very often a very large number of different tools that you can use. I've found that although there's vast functionality, there tends to be a very steep learning curve. It's almost like there's so many different things that the software can do that it can take a very long time for you to learn how to do even simple things with it. So this software is generally designed for use in graphics, not so much manufacturing, and because of that, it's more likely to result in the types of issues I've described for printability. It's more likely to result in holes and interference because it typically doesn't have default tools enabled that will prevent those things from appearing. So if you are working in this type of software, you'll have to make sure to be careful that those things don't show up. So one of the benefits of this type of software, even over Magix, is that it has very powerful and precise control over texture mapping. Again, you'll need to probably climb a steep learning curve in order to harness that capability, but if you get there, then you'll have a huge amount of control over how you want your color files to appear. So the example I'm going to demo for this type of software is Blender. So Blender is great for a couple different things that I'm going to show you. There's mesh manipulation, some very useful modifiers, which are useful not just for applying color and texture, but also for solving the types of issues that you may encounter. And then I'll touch a little bit on applying color and texture, but as I've mentioned, it's such a huge topic that it's not really something that can be explored deeply in a single webinar. So here's Blender. Already it has a fairly busy interface, but I have a Dr. Pepper can open here. So some of the things that are quite easy to do with Blender that are not easy to do in Magix are things like selecting one portion of a model and quickly scaling it down or up, or even rotating it. And these things are not useful on a Dr. Pepper can, but oftentimes on other models, it can be very helpful to grab a portion of geometry individually and move it around. So some of the things that I've found that are useful are this modifier page, which gives all sorts of different powers. One of these is remeshing, which can help to take a surface that is very damaged, such as a surface from a scan model. That's what I found this most useful for. Oftentimes when you scan a physical part in order to create a geometric model from it, the surface will have holes and other problems with it that can be challenging to solve using most other modeling methods. So something like this remeshing tool can make it much faster to get a workable, printable part. And again, there are all sorts of options here that we don't have nearly enough time to go through. So one thing I wanted to look at quickly is the Appearances tab, or the Material tab. So this tab is what allows you to apply different types of images and colors to a part. Right now there are two types of images connected to it right now. One of them is the Dr. Pepper logo, and the other is just the light gray that you see on the top and bottom of the part. So if I wanted to, I believe I could find that gray here and adjust that color. Here it is. Oh, it's actually working from an image file. So I'm actually going to change this to RGB, and I'm just going to adjust these sliders, and now you can see that the gray is getting darker. So again, all sorts of options, and you need quite a bit of experience to harness them. But if you are looking to do very complex coloration and texturing, then this type of tool can be very useful. Blender is also open source. There are many other options in the industry, including Maya and some other sort of animation studio programs, and in some cases those can be a little easier to pick up with less steep learning curves. So finally, I'll talk about our OneTouch software and what functionality we offer for the purpose of creating color models for printing. So one of the benefits of Rise software is that it has a markup mode integrated into the slicing software, so you don't have to work with multiple tools at once. You can just open the Rise software, apply your markups, and immediately send it to print. It allows you to quite easily apply colorful text and image markups. We have a tool called just markup mode, and that has the built-in capability to do text, which is a little more difficult to do in most of the other softwares that I've shown you today. It also has some rudimentary capability to apply markups wrapped around simple curves. This is a fairly new function that is still under development and constantly improving, but already it has the ability to do a lot of effective wrapping of different textures on some simpler geometries. And finally, one of the main benefits of working within Rise software is the ability to duplicate or differentiate markups across instances and in a single build. So if you have a single part that has a set of color and image information on it, and you want to apply additional markups to it, but you want each one to have a set of different markups, then our markup mode can very easily allow you to do that. So I'm going to now open Rise software, where I already have one part loaded into it. So I'm just going to open markup mode and give a quick example of applying a texture to it. So first I'm going to orient the view here, and then I will open a picture. So we already have an orange one. I decided for this one I want it to be this green by a 10 alive. So hopefully it works. So I'm going to scale it up a little bit, and then try wrapping it all the way around. So here's where the wrapping functionality is. Gives you three different options. Right now I have 360 degrees chosen. Not sure how that's going to work, but exactly what I wanted. Perfect. So in addition to applying images, we also have this text button where I could type some text and apply that onto the surface. Oh, still have wrap selected, so I'll project it straight onto the surface. And then the other useful effect of this is that both of those two markups appeared over here in the existing markups box. So if I wanted to modify them. For example, if I wanted to change this back to orange, then I could either select this orange texture and it switches back, or I could just delete the texture since I already have orange attached. I could also select this text and maybe change the font to something else like this, and it automatically fixes it. All right, so now I just wanted to go over a few of the useful methods of adjusting or repairing the different color model files that you might encounter. So one of the major things that I've encountered is in OBJ and MTL files. I often find that the references that were created in the original file have been broken by changing file names and things like that. So one of the things I wanted to look at was opening an MTL file and looking at the references and seeing how those work. So I'm actually going to open the Dr. Pepper one first. So an MTL file is typically quite short and it's plain text, so you can read exactly what it's saying, and it's written in a sort of code, but it's not that complicated to understand. So this is the Dr. Pepper image file. You can see that there's first the main part of the can with the image attached, and then there's the gray part at the top. Now, most of this information cannot be printed by the 3D printer. In fact, the only things that are useful to Rise software are KD and MapKD. And those are the two that I listed up here, KD and MapKD. And the D stands for diffuse, which is the type of texture that we're applying. So I'm actually going to delete all of these things. And now this is the entire texture there, just 3 lines, and that's all you need in order to print it. So I'm not going to save that, but I am going to now hop over to this Bioten set. So this material file only has 3 different materials. It has the this part here is the cap, which for this part is orange. Then it has the white color used for the background of the tube, and then it has the image file that's wrapped around the top part of the tube. So if I wanted to, I could actually just change this word right here to alive instead of bright, and then this Bioten alive image would be referenced instead. So that's another way that you could change the image file, is just by changing the reference in the material file. It gets a little more complex if you want to do what I've called remapping and consolidating MTLs, but one of the things I've done here is taken both of these OBJ files and caused both of them to reference the Bioten Bright MTL. So although I have separate OBJs, I only need one MTL file, and both of them will reference through that in order to find the correct materials. So if I were to open these, you can see that this one is orange with rounded corners, and the other one that I have here should be the same but with sharper corners. So both of these are referencing the same MTL file, and the MTL file is of course referencing the same image file. So this is a way of, in some cases, taking a large number of slight variations of a single part and mapping all of your OBJs to a single MTL so that you don't need a huge mass of files to keep things connected. And it also means that if I were to take this material file that I just changed and save it, then now when I open those 2 files, both of them will have changed their colors. So that they both now have the green alive texture, and I didn't have to do that individually, so I could have a dozen different versions of this, and just changing the MTL would allow them to change together. So the way that you do that is to open the OBJ with Notepad. Like I mentioned, it's plain text, so you can read all the coordinates, and then all you have to do is Control F MTL, and that'll take you to all of the MTL references. So right here it says use texture MTL, or use MTL texture Bio10 bright, and that is this texture right here. So really the important part here is that this word right here, bio10bright.mtl, is the same in both of the OBJ files, and that ensures that they're mapped and consolidated to a single MTL. The other thing that you can use that functionality for is fixing missing image files. So one of the things that I often encounter is you try to open an image file and it's missing, or you try to open a color model and it says that it's missing images or it's missing references, and it will be shown in gray rather than the full set of colors that it's supposed to. And the way you can solve that is by opening the OBJ and MTL files and just checking through the references by using Control F MTL in the OBJ file. And that will allow you to make sure that all of the images that you have included are named correctly and that there aren't any erroneous file paths. I'll show one more quick example of that if I can. All right, so one of the things you could encounter is, as I mentioned with this brainstem, if we were to open the brainstem, open it in Rise Software now. As you can see, all of these colors are moved in incorrect places, and the reason for that is that I changed the image file itself so that the image was rotated 180 degrees. So this is sometimes something I've encountered, not with this particular file, but basically what happens is it just jumbles all of the references up so that nothing is colored correctly, but all it takes is rotating this part. Now it's good. So if I add this as a new file, now you can see all of the correct colors. So if you learn your way around MTL files and the OBJ format, then it can make you quite effective at resolving any issues that you might encounter. And it is quite common to encounter issues with references and the different images when you're working with color file types across all different types of software. So it's a useful skill to develop if this is what you're looking to do. All right, and that is all I have for today's webinar. Thank you all for joining us. I'm going to stick around for a few minutes to answer any questions you might have. If you do have questions, you can add them into the chat window at the bottom of your GoToMeeting panel, and I'll stick around and answer them. And once again, please have a nice day.